This is the video to go over the study guide. The unit on inequalities is very similar to the unit on equations. A lot of these concepts we've covered, so I'm just going to quickly go through all the different types of examples. Question number one asks you to translate into an inequality. So straight off the bat, you don't even have to pretend to think if it's an equation or an expression. It's definitely going to be inequality, so it's going to have one of the four inequality symbols. Some of them are trickier than others, but we know we're going to have one of those four symbols in all of our inequality examples. A says 8 less than a number is greater than the square root of 9. So we see the word is, but it's actually is greater than, so it's that symbol, is greater than the square root of 9. You do not have to evaluate that and make it into 3. Please don't do that. Leave it as the square root of 9. Another tricky thing is the word less than, so it's 8 less than a number, less than opposite. B, the difference of twice a number and 7 is, so we see the word is, but it's not equal, it is at most. Is at most is tricky. You see most, and I know you want to think one of these guys, but is at most actually means is less than or equal to, so it's is at most 4. The difference, which means subtraction, the difference of twice a number is not squared, so if you put x squared, that's incorrect. It's twice a number times 2. The difference between twice a number and 7 is at most 4. C, the sum of a number squared and 1 is at least 30. So we see the word is, but it's not is, it's is at least. Again, least, I know that you're thinking this guy, but it's not. Is at least means is greater than or equal to, so it's is at least 30. The sum, which means addition, the sum of a number squared, that's where we put a number squared, and 1. So the sum, which means addition, of a number squared and 1 is at least 30. D, negative 44 decreased by a number is, but is greater than the square root of 2. So is greater than the square root of 2. I like to do that part first. Then I come back to the other part. Negative 44 decreased by a number, let's say b in this case, is greater than the square root of 2. E, the quotient, which means division, not multiplication or subtraction, of a number and 2 decreased by 5 is, but is less than 0. Okay, let's go back. So the quotient of a number and 2, quotient means division. The division of a number, let's say m and 2, decreased by 5. So I put it as a fraction. You could have put the quotient of a number and 2 decreased by 5. That would have been fine also, because order of operations says we do that first anyway. I like fractions, though. It's a little bit cleaner. F, the product of a number and a different number is, but it is at least. So it's not is, it's not least. It is at least, it is greater than or equal to, is at least 10. The product, which means multiplication, the product of a number, let's say x, and a different number, let's say g, x times g, is greater than or equal to 10. You don't have to put the dot between them. If you had just put, instead of x, if we put p times g is greater than or equal to is at least 10. That would have worked also. Question 2 asked us to write the inequality that's represented on the number line below. So there's 3 different examples. We have to answer all 3. This first example over here, we know that it's not filled in, therefore there's no line underneath, and I know that whatever variable I choose, it doesn't matter, let's say k. I know that 6 is on the other side, that's my number. If I do the same thing here, I know that whatever variable I choose, let's say w, I'm using 3. On this case, whatever variable I choose, let's say h, I'm choosing negative 1. In this example, it's not filled in. In this example, it is filled in, so I know that there's a line underneath. Let's do this one while we're here. Since the variable is shading in the small direction, we want the variable in the small direction for my symbol. Same thing with this one. Since we're shading in the smaller direction, we want the variable to be on the small side of the inequality symbol. In this example, since we're going to the bigger numbers off to the right, W needs to be on the big side of the inequality symbol, so we make our like that. You could have flipped any of these around, like for example, this one, instead of k is less than 6, you could have made it like this and put the variable on that side, but the variable still needs to be on the small side of the inequality, otherwise it will not be accurate. Question 3 is a great question. These questions, the type of question we see on the SOL all the time, where they give you options. You have to get them all correct or you're wrong on the SOL. I'll show you why it's a great question. I love to ask it. We still split it down the middle, solve the same way, subtract on both sides. It's called the subtraction property of inequality, because it's an inequality, not an equation. We bring down the negative 2d on that side. Make sure you bring your symbol straight down. 9 minus 1 is 8. You don't flip. You only flip when you multiply or divide by a negative, not subtraction. Subtraction doesn't flip anything, only multiplying and dividing by a negative. Speaking of which, we divide by negative 2, divide by negative 2. We get d on the left side. 8 divided by negative 2 is negative 4. And since I divided by a negative, this symbol will now flip. So d is less than negative 4. We're looking for any values that are smaller than negative 4. The most common wrong answer is to circle negative 4. That is not an answer. I know you see negative 4, but negative 4 is not the right answer in this case. Negative 4 isn't smaller than negative 4, so that's wrong. 4 is also not smaller than negative 4, neither is 5. What is smaller than negative 4? Negative 5 is smaller, and negative 11.2 is smaller. On the SOL, you'll need to circle those two and only those two in order to get question 3 correct. On question 4, I briefly mentioned these properties. When you do the same thing to both sides, that is called the subtraction property of, if you put of equality, that's wrong. It's not the subtraction property of equality because this is not an equation. It's actually the subtractive property of inequalities. Same thing down here. If you notice, both sides got multiplied by 5 to solve. This is called the multiplication property of inequalities. Easy questions if you have that memorized. Question 5, solving graph, and these are easy. Let's go do them quick. Split it down the middle. Someone added 8. I subtract 8 from both sides. We have x. It'd be a shame if you get a question like this wrong because you just didn't use your calculator. It's not negative 4. Do keep, change, change. They work together. That's negative 20. And the symbol does not flip because I subtracted. It's only when you multiply and divide by negative. Circle your answer. You put negative 20. Let's do 1 on either side. Remember the negatives are backwards. Close circle because there's a line underneath. X is on the big side, so we go to the right. This one over here is a little bit trickier because we have a negative variable. So paying attention, we'll split it down the middle. I know you want to add 2, but the 2 is positive. So I get rid of that 2 by subtracting that 2 away. That will make a positive 2 and a negative 2. Those will now cancel. 18 minus 2 is 16. Symbol stays the same. And I bring down the negative 4a. That's probably the hardest part of the whole thing. Undo by divide by negative, divide by a negative, I get a. 16 divided by negative 4 is negative 4. And since I divided by a negative here, this symbol now flips. All right, negative 4 in the middle. Remember the negatives are backwards. Line underneath, so it's filled in. A, as you can see, is on the big opening. Since it's on the big side, we want to shade to the bigger numbers to the right. Yes, I know it doesn't look like negative 3 is bigger, but the bigger numbers are always to the right. Split it down the middle. Someone divided by 3 and added 4. We undo doing SADMAT, so reverse PEMDAS. So we undo addition, subtraction first. Minus 4, minus 4. M divided by 3 is what remains on this side. The symbol stays the same. Don't put negative 8. Remember, you have a calculator. Keep, change, change. Negative 12 and negative 4 is negative 16. Multiply by 3. Multiply by 3, and I get, that cancels. I get M. On this side, it's negative 48. And the symbol does not flip. Circle your answer. It does not flip because I multiplied by a positive. I know there's a negative already there, but since I multiplied by a positive, it doesn't flip. Again, it flips when you multiply or divide by a negative. You multiplied by a positive. Make sure you label. It's an open circle because there's no line underneath. M is on the big opening, so we go to the bigger numbers, which is to the right. Very simple one step here. Split down the middle. Don't add 5. It's negative 5 times g. That's a problem we really need to get over. It's not negative 5 subtracted by g. It's negative 5 multiplied by g. So I undo multiplication with division. Divide to undo multiplication. Divide on both sides. We get g. 55 divided by 5 is 11. They're both negative, so it ends up being a positive. And since I divided by a negative, this symbol now flips. 11's in the middle. We do 1 on either side. Open circle because there's no line underneath. G's on the big side, so we go to the right. All right. Question that we tend to get wrong quite a bit. I know you're very tempted to undo the addition. However, these are really parentheses. When we talk about SADMAP, parentheses is the last thing that you undo. First thing we have to undo is division, because addition and subtraction don't really exist. That's parentheses. I do times 10 times 10. It leaves me with n plus 5 on the left, and on the right, 10 times 6 is 60. Now it's a one-step minus 5 minus 5. I have n, 55, symbol stays the same. 55 in the middle. Or open circle ends on the small side, so we go to the left. Split down the middle. Undo by adding, This is gone, and I have 1/3 y is greater than or equal to. Use your calculator if you need to, but you should know that they are different. They fight. The negatives win by 1. All right, get in the habit of multiplying by reciprocals. So I multiply by 3 over 1, or 3, because those both cancel. I multiply by 3 on that side also. Symbol stays the same because I multiplied by a positive, so it's negative 3. Y is greater than or equal to negative 3. Negative 3, negative 2, negative 4. Closed circle, Y is on the big side, so I go to the bigger numbers. All right, another 2-step down here, split it down the middle. Minus 1.5, minus 1.5. If you weren't using a calculator before, you certainly need to use a calculator now. 39.1 minus 1.5 is 37.6. We divide both sides by 4.7, divide by 4.7, and we get x. The symbol does not flip, and 37.6 divided by 4.7 is 8. So it ends up being a nice answer. 8 in the middle, 7, 8, 9, open circle, x on the big side, so we shade to the right, the bigger numbers. Split down the middle, undo minus 7 by add 7 to both sides. We bring down the negative 9x is greater than 45. Divide by negative 9, again, that's multiplication. We undo it division. We get x. The symbol does flip because we divided by a negative, and it's negative 5. Circle your answer. Negative 5. Remember the negatives are backwards. Open circle, x on the big side, so we shade that direction. All right, once again, we have fractions, decimals. If I can make a suggestion, you could deal with that fraction because it's not too bad, but you could also just turn it to a decimal in this particular case because 1/2 is 0.5. Minus 0.5, minus 0.5. You get negative 3a is less than 7.5. Divide by negative 3, divide by negative 3. We have a. The symbol does flip here. We have a negative 7.5 divided by 3 is 2.5. Negative 2.5. Circle your answer. When we label this one, we could label a little bit differently. Negative 2.5 right here. So you could put negative 1.5 and then negative 3.5. You could do that. You also could do, let's say this is a negative 2, and then this is negative 3, because now we're going by a half and by a half. You also could do negative 2.4 and negative 2.6. Just depends on what unit you're measuring. In this case, I'm measuring by tenths. Doesn't really matter because I'm going to have an open circle. A is on the big side, so I'm going to shade to the right, which is where the bigger numbers are. A couple of word problems to finish this off. We want to write the inequality, and then we write the answer in words. Some of you guys like to take this and then translate it. That's not what we're asking you to do. We're asking you to solve it and then talk about what your answer actually means. So let's do question 6. Riley was saving up money to buy the newest Apple Watch. His parents told him they were willing to give $200. Riley decided to babysit at $15 an hour to raise the rest of the money. If the Apple Watch costs $450, what's the least amount of hours Riley would need to babysit? So $450 is really our target. You could say we want to be equal to $450. The amount of money we have needs to be equal to $450. Or we could think of it like this, since it's an inequality. We want to have at least $450. So what we get needs to be bigger than or equal to $450. So if we're more than that, we're in good shape. We just have extra money, or Riley does. Now he has $200 already that his parents gave him. We're going to add to that $15 an hour. $15 for every hour. The word per or per hour is usually multiplication. $15 for every hour plus the 200 has to be greater than or equal to your target of $450. Again, you either get all this money or you get the watch, which costs $450. A little bit of opportunity cost. We're not ready for this yet. We're not translating that yet. We have to solve this first. 15h plus 200 is greater than or equal to 450 minus 200 minus 200. We get 15h is greater than or equal to 250 divided by 15. Divided by 15, we have h is greater than or equal to 250 divided by 15. It is 16.6 repeating. So 16.6 repeating hours. Since it's time, 2/3 of an hour, 0.6 of an hour is really 40 minutes. So it says the least amount of hours. That's kind of tricky, right? So since h needs to be bigger than 16, if he only babysat 16 hours, would he have enough money? No, because he needs that extra 6/10 to reach 450. So since we need at least greater than or equal to, this is be bigger than 16, we want to say Riley should babysit for 17 hours. Now, if you made the argument 16.6, I get that because you could have 2/3 of an hour, but we're talking about rounding here intentionally. Question 7, another word problem, same idea. Maxwell started his own company selling custom nameplates. Maxwell charges $12 for each nameplate, then another 35 cents for each letter the teacher wants printed. Mr. Colacello wants to buy a nameplate with the word Colacello written on it. If he has $15, does he have enough money? Okay, so $15 is what Mr. Colacello has. The amount of money he spends on this has to be less than or equal to 15. Because if this, the amount of money he spends on his nameplate, is bigger than 15, he can't buy it. So Mr. Colacello either has the $15 in his pocket or he gets this. This is an inequality, so you have to remember one side has to be larger than the other. So $15 is what he has, and then $15 needs to be more than the cost that he spends. If he spends more than that, he can't get it. Now, it's $12 is the cost of the nameplate plus 0.35 for every letter. We'll do an L. Let's use this and solve. That's what our answer is. 0.35 L plus 12 is less than or equal to 15. So this is going to determine how many letters. That's what L stands for. If it's 35 cents per letter, we can find out the maximum amount of letters that Mr. Colacello can get. Minus 12 minus 12. 0.35 L is less than or equal to 3. 15 minus 12 is 3. Divided by 0.35. This will determine the number of letters. The number of letters he gets has to be less than or equal to, let's see, 3 divided by 0.35 is 8.57. So can he get can he get 0.57 of the letter, 57 hundredths of the letters? No. So can Mr. Colacello get 9 letters? Can he get 9? No, because the number of letters has to be smaller than 8.5. So the maximum amount of letters that he can get is 8. Well, let's see. How many letters are in Colacello? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unfortunately, no, he cannot. Colacello has 10 letters, but he can only get up to